through the topic research, then making the script. After scripting, you are going to screen it, making the video and audio production. So in between there is a copyright and IPR. So after recording all your project, video project, final product, you are uploading in the Google Drive, and you are creating one link, that Google link, that is shared with the BISAC. So by that way, you are creating your content and uploading it in the Google Drive. That is also going to Diksha portal also, BISAC also, for the telecast as per your schedule, monthly schedule. So all till now you have done all these things in the recorded mode. But what we will do if we have to telecast in the live way, if we have to stream it live, till now everything was going to be done in the recorded mode. If suppose in your school, in your college, class, everywhere, anywhere you want to live stream your video content, so how will stream it? So till last 2 days, I hope, if you have not introduced about the encoder, here encoder comes and play a big role to streaming your video content, audio content in live. So today I will explain about the encoder, its features, uses in video streaming. So first we will talk about it and for the playback purposes. So this is the encoder, what I was talking about. So we have taken the analog signal, we have converted into a digital one, but why it is required to convert it to digital and then compress it? So till now you are doing all your content in the recorded mode, you have sent it to the BISAC, and BISAC is uplinking to the satellite. So from that portion you are not activated in that, you are not involved in that. You are given the signal to BISAC, BISAC has uplinking it, and by the picture you are getting at your home, your viewers are getting at your home. Up there downlinking, there is a DTH at their home, they are by the remote they are switching on and they are viewing their channels. But what if you have to live stream? So something will be happen like this. You are recording your video at your source, you are uplinking the video from your source, and then your viewers are going to downlink it through the DTH. By, like we are seeing the programs in the house. One TV is there, set-top box is there, there is some antenna through which we are downlinking the signal. So when we are going to uplink, we are encoding the signal. Our set-top box at the home is working as a decoder. So we are encoding, our set-top box at home is encoding this, decoding the signal. So why to use encoder? There is something about the storage, there is something about the bandwidth limitation for the transmission. Suppose we have 100 GB of data and we have to transmit it over the internet or satellite. So how complex it should be? If we have a data of 1 GB and we want to transmit it by seconds over the internet, it requires a large speed of internet. That is not feasible, that is not available everywhere, and it will be difficult because your data will get break. It will be like buffering, like we were watching the videos in the 2G format earlier. So the video will be not simultaneously playing, right? And here I will say how we are recording the video. Suppose in video, we are taking the frames. So in India, we are adapting that PAL system, phase alternation by line. So in that, if we have to record 1 second of video, we are taking 25 frames, that is 25 pictures. So that 25 pictures are moving and our eye is visualizing that it is a motion, like that video is creating. So for every 1 second, there is 25 pictures, 25 frames. So suppose if we are recording from our mobile, and if in a HD, high quality HD, 1920 to 1080 pixels, and each frame is about 1 MB. So for 1 minute, it is required around 1500 images, 1500 MB of data is required for 1 minute. So it is around 1.5 GB, right? So that much bulky data is difficult to handle in transmission, difficult to handle in live streaming. That what we are seeing now in digital revolution, in OTT platforms, video on demand, on YouTube, these things may not happen if we have to transmit that much bulky data. So that's why encoder is here a magical thing that is compressing the data, digitizing, packaging, and multiplexing it. This is a simple example. If we are recording our video, audio in raw file and then transmitting it, how much storage is required? So suppose we are talking about the HD video. So pixel is 1920 into 1080 pixel. And in India, we are following 25 FPS for the video recording, 25 frames per second, and 8 bit per pixel. So each pixel is of 8 bit. And if we are taking 3-chip camera, red, green, blue, generally we are using single chip camera. If we are taking 3-chip camera, so red, green, and blue or colors will come separately. So for 1 second of video, you need around 150 MB of data or storage, right? So like that way, if you calculate for 1 minute of video, it is required around 9 GB. 9 GB of space is required. So now after 4G has come, 5G has come, and we are getting a 1.5 GB of data every day free in India. So you see how much video you can play in a day if you are streaming or you are recording a raw video. Hardly you may watch around 10 seconds maximum for 1.5 GB data, right? Similarly, if we are going to record a raw audio, this example is taken here as a CD quality, not a HD quality, not a web quality. It is a CD quality, not a broadcast. Lowest quality is it is. For CD, sampling frequency, per second is 44.1 kilohertz. Simply we are multiplying and we are taking the bit per sample 16. If we are taking a stereo, multiply by 2. If it is a mono platforms, if encoder was not there. Encoder has evolved from 1800, and now we are using the technology of 2000, that is AVC, Advanced Video Codec, Advanced Audio Codec, that is commonly known as H.264. That format is going to be used. So when we are talking about 10 GB of data per minute, and now we are compressing it. So how it is affecting it, how we are experiencing through our visual, and why it is accepted, why compression is accepted, how we are compressing 10 GB of data into 100 MB. Okay. So this is a small activity. There are 3 images. Since video is formed by images only, frames only, there is nothing called video, it is a photos, images. So 3 images are there, all are compressed. So these are the limitations of our eyes, which is not able to identify which one is the best using the encoder as compression. So you may say which one is the best quality, higher in size, and least quality, lower in size. Any guesses? Which one is the best one? Number 3 is best one. Okay, let's see. First one is 448 KB. Second one is 298 KB. Your guess was right. Third one is the best picture. But when you are seeing visually, you are finding any difference? If it is a 1 MB of file or it is a 298 KB, right? So by this way, encoder is compressing the data so that you will get the best quality with lower size, lower bit rate. So it will consume less data, less storage, less bandwidth, right? Okay, similarly, one more example is there. Here I think I have taken more bigger size of data. So what will be your guesses here? What should be? Which one should be the best one? So I think only 3-4% has guessed the right, so their visual is very good. So other has been accepted the compression. I think there was no any doubt, right? So compression is accepted, right? So here I have taken some bigger size. One is the best one, right? Any other cases? 2. Right. Let's see. This was the first one. This is 298 KB only. What was the answer? Second one? 3. Okay. So I think by visualizing the different types of picture, we are accepting the compression. We are not clearly able to find out which one is better. So by that way, encoder is creating the compression. So basically, what is the key of compression? How we are compressing? So redundancy of data. Redundancy of data. In 25 frames, each frame are taken in 1 second. So there is some redundancy. Nothing is vastly going to be changed. If I am taking on one video here, maximum what is going to change? Lighting, background will be same, some contrast will come. So nothing is going to be vastly changed. So from one picture to another, we are reducing the redundancy. Okay. So this is a simple block diagram of encoder. Actually, encoder and decoder comes in a pair. We can't separate it. So decoder is also shown there. So when we are taking a raw video, it is going through a codec, that is coder, encoder. And for video, different types of coders, and audio, different types of coders are there. So like just now I have told you about H.264. That is the latest codec we are using for MPEG-4, and that is mostly used in the all content distribution platforms. And we are taking the original audio. Similarly, we are using an audio codec, and now we are using in MPEG-4, that is advanced audio codec. Though both the files, after getting compression, it is encoded together. So in encoder, there is 3 processes happening. It is encoding the data, means it is taking the analog signal and converting into the digital signal. Then it is compressing it, digital signal. After compression, it is going to be divided into packets. That packets are going to be streamed. That packets are going to be transmitted to decoder. That digital packets are not taking only the information, but they are also taking some header information, some IP information if you are going to transmit through the internet. So destination IP address and port number. Also with that packets, we are sending the metadata. We are sending the subtitles, if any. So all these files are going to be multiplexed, and finally output stream is coming out from the encoder. So once we got the output from the encoder, similarly there is some destination. Suppose we are sending our signal from here to Baisak, Gandhinagar. So encoded signal is going to the Baisak. There decoder is there. Decoder is a similar device, just it is doing opposite of the encoder. So they are taking our output stream through the IP, same IP address with the encryption. So when we are transmitting our data, it is transmitted through encryption, so that there should not be any loss, it should not be hacked, it should not be taken down from somewhere else. So encoder and decoder is doing the work like this, and this is a simple analogy of encoder and decoder, how it is working. So you may read there, like suppose we have to get an orange juice at our home, or suppose we are getting, any supplier is there who has the orange farm and he has to sell the orange juices at our home. So what will be the convenient way? So sending directly orange from the farm, it will be difficult for the transmission. that is transportation, sorry, not transmission, transportation. Again, the user or consumer has to purchase the oranges, they have to take it at home, peel it off, and they have to make the juice. Okay. So if we relate it with the encoder, what supplier can do? Supplier can take an orange, make orange juice from that oranges, and convert it into a concentrated form. Remove that water from that orange, make it a powder, and then supply it to the all over India or any other places. So what he has done, he has removed the storage cost. Suppose he is sending around 1 truck of apples. In that place, he can sold small pouches that may contain lakhs of pouches in that same space. Similarly, in encoder also, 10 GB of 1 minute of data is converted into 400, 300 MB, depending upon the different types of codecs, right? Then we were talking about the compression, and compression key part is redundancy. So how we are removing the redundancy, what types of redundancy are there? So when we see about the picture, it is made up of two things. First one is luminance light, and second one is chrominance, color. Two things are there. So when we are visualizing it in the spectrum, we are seeing it luminance and color, R, G and B. So here when we are using MPEG-4, we are taking light and difference of color. So R minus G, R minus B. So first one is spectral redundancy. So when we are doing the sampling, we are taking only maybe images, yeah. So when we are doing the spectral redundancy, we are removing the redundant data. What we are doing, suppose we are sampling, our original format is 4:4:4. 4 is luminance, 4 is chrominance, R minus G, 4 is R minus B. So this is a standard format. So when we are removing from the chrominance part from the picture, it is coming as a spectral redundancy. How it is happening? Because of the limitation of our eyes. Our eyes are more sensitive to light rather than color. So when we have moved to MPEG-2, we were using 4:2:2. Then after in advanced version, when we are moving to MPEG-4, we are using 4:2:2. Still in some variants, we are using 4:2:2. So luminance is, we are taking full luminance portion, full luminance samples. So 4 samples are there still in the original format, still in the all the advancement of the codecs, either is MPEG-2, MPEG-4. But by the advancement of codecs, we are removing the color part, because due to the limitation of eyes, we are not getting much changes in our video, right? So this was the spectral redundancy. Similarly, there is a second part, spatial redundancy. It was above, yeah. Okay. ठीक है, ओके, थोड़ा शॉर्ट में करता हूँ. Okay. So in spatial redundancy, what is happening? We have 25 frames of pictures in 1 second of video. So in 25 frames of picture, single frame. So first image, still it has similar data, many pixels of same data. So only particular data is going to be transmitted over the internet, and all other data is going to be left out. So suppose it's 1 MB of data, we have divided it, it is coming around 50 KB. So in that 50 KB, we are sending around 1 KB. Because all the pixels have same data, we need only one data. After compression, we are going to decode it, and we are going to reconstruct the data, right? Third one is similarly, it is the temporal redundancy. In temporal redundancy, we are in out of 25 frames through the encoder, we are sending only 1 frame. So see how compression is going to be done. In 25 frames, we are sending only one frame. So 24 are left out. And on the basis of first frame, we are predicting the next frame. Out of 25 frames, we are sending one frame. And on the basis of one frame, we are predicting the next frame. And on the basis of first frame and the predicted frame, we are recreating all other frames. So out of 20 frames, we are sending only one frame in original, and all other things are going to be recreated by the decoder. Right? Then, so these things were how it was happening. I think I'll skip this one. Okay. So there are two different types of codecs which are doing the compression. So it is a lossy and lossless. Definitely if we have 10 GB of data and we are compressing it to 500 MB, it is a lossy. Right? It is a lossy. And second one is the lossless. That is also a lossy, but we are compressing only 50% of data. So for all the content distribution platforms, live streaming, OTTs, Facebook, YouTube, Netflix, everywhere, we are using the lossy codec. Lossless is only used in the post-production and editing, where we need clear data so that it can be perfectly edited in the post-production. And still, lossy examples of lossy are advanced video codec, high efficiency video codec, and for the audio it is MP3 and advanced audio codec. Similarly for lossless it is the VP9, Lagarith, and FLAC for the audio. Yeah. So there is some doubts, ma'am. Yeah. So here, okay. So we have sent the first frame at original. That is the intra frame. On that basis of first frame, we have created the P frame. That is called predicted frame. Okay. On the basis of intra frame and predicted frame, by the interpolation, we are creating the B frame. That is bidirectional interpolation. Right. So on the basis of first frame, we are creating all those frames, 25 frames. Ready? So these are the different types of codecs available for audio and video in the market, and whatever devices we are using. Knowingly or unknowingly, we all are using the codecs. That is the best example is our mobile phone. Any devices where you are viewing or watching a media, that is using a codec. Either you are watching on a mobile, laptop, tablet, or you are watching from the YouTube, watching from the OTT platforms, Netflix, everywhere codecs are used. Otherwise, without that, the content revolution and digital revolution might not have happened. So these are the uses and application for the broadcasting, definitely to reduce the transmission bandwidth, because sending a large bit of information, large data, it required more bandwidth. So we are reducing the bandwidth. So for broadcasting, satellite or cable TV, similarly for live streaming. Otherwise, if you are sending a raw data for the live streaming, you may not able to see your video. It will be buffer. You will not get continuous video playback, right? Similarly, it is for the OTT platforms, video on demand, and it is making more feasible to distribute content from one place to another, from your mobile to my mobile, from your Google Drive to sending to some other person. So without encoder, these things were not happening. So this is the part when we are doing the live streaming, or our recorded signal going to be live telecasted. Live streaming does not mean we are streaming it live, but we are not live. It may happen. Suppose you have recorded a program and scheduled it, and it is going to be live on that particular time. That is also live streaming. Okay. So we have encoder at our place where we are doing the live telecast, live streaming. And through the internet, over the internet, we are sending our encoded data to the BISAC, Gandhinagar. From there, they are getting the data from the decoder. After getting decoded and multiplexing, modulation, all those things, that is going to be uplinked to the satellite, GSAT 15, I guess. And And after that, it is going to the viewers, consumers. They are taking the data through the DTH and receiving at your home.
लाइव सेशन और लाइव स्ट्रीमिंग दो अलग अलग चीजें हैं।
दोनों एक ही चीजें हैं सर। लाइव सेशन चल रहा है तो आप लाइव बैठे हुए कैमरे के सामने बोल रहे हैं, वही आउटपुट जो है आपका लाइव स्ट्रीम्ड हो रहा है,
ठीक है।
वो चला गया। सपोज दूसरा है कि आपने कोई वीडियो रिकॉर्ड करके रख दिया है
ओके।
और उसको आप लाइव स्ट्रीम करना चाह रहे हैं।
ये लाइव स्ट्रीमिंग का मतलब समझ में नहीं आया, ये तो
स्ट्रीमिंग एक तो लाइव सेशन में मैं कैमरे के सामने बैठा हूँ, वही आउटपुट डायरेक्टली जा रहा है सेटेलाइट पे,
ठीक है।
राइट सर। और दूसरा है कि बेस्ट एग्जांपल इज हमारे प्राइम मिनिस्टर का कुछ स्पीच होता है, उनको कुछ देना है, वो अवेलेबल नहीं है पर वो शेड्यूल है, उसी दिन जाना है, पर आप जिस भी चैनल पे देखोगे आप लाइव जाता है, वो परीक्षा पे चर्चा लाइव जाता है, मन की बात लाइव जाता है, पर मोस्ट प्रोबेबली वो लाइव नहीं जा रहा है। दो प्रोग्राम्स आर रिकॉर्डेड बिफोर हैंड, सो उस तरह के कंटेंट रिकॉर्ड करके फिर वो लाइव कर रहे हैं पर्टिकुलर टाइम पे।
तो इसका मतलब सारे प्रोग्राम लाइव स्ट्रीमिंग ही होंगे, जो भी रिकॉर्डेड प्रोग्राम है अगर वो किसी टाइम पर कर रहे हैं तो।
अगर इसके थ्रू कर रहे हैं आप, इनकोडर के थ्रू और सैटेलाइट के थ्रू, वो लाइव ही होंगे डेफिनेटली। This is the encoder we are using at our studio, that is the reverse silica PixFix encoder. This is just for the purpose. It is the front view of encoder and back view of encoder. We have installed the encoder here for the practical demo also, so that you can see the output directly. Just I am giving a brief of what are the available input and input interfaces and stream in the PixFix encoder. These are the available outputs. So, sorry, do you have seen the encoder anywhere? No, there is no live streaming, right? So, this is the encoder back view where we are giving the inputs. Mainly we are using the 4 connections. In any encoder there are 4 connections, minimum basic connections. So where we are giving a power supply, one input, if we are transmitting the data through the internet, one internet port, and one interface, web interface for the management, that is called management port. So through which you can see or you can give input to all the settings of the encoder, right? So here first one is the power supply, second one is the BNC input, that is BioNode Navy connector input. So all the SDI input is going through that, and third one is the internet port through which we are transmitting our encoded data to BISAC, and fourth one is the management port web interface. हाँ जी, अभी वो कनेक्शंस आएंगे तो मैं बताऊंगा इनको। जितनी as I said, encoder and decoder comes in pair. They are not coming individually. They are in pair. So if we are keeping encoder here and decoder is in BISAC, so encoder and decoder should be paired through the internet protocols and port. So that thing is going to be done by the BISAC. Sir will explain much better in that. And by that way, we are pairing our encoder and decoder, and our data is going to be transmitted over internet through our place to BISAC for uplinking. This is the same input connections and output connections has been shown. जी. So encoder, when we place the encoder, what should be the precautions and safety measures we have to take? Preferably, we install the encoder in the control room where our production is going to be happen or our production is happening, so that final output from there, if we are live streaming, the final output of the audio video, multiplex audio video can be given directly to the encoder. It should be kept in dry, clean and well ventilated area so that it should not lag. It should be covered under air conditioned, and we have to maintain the ambient temperature up to 35 degrees Celsius. Earthing is important. It should be maintained. Otherwise, if you are going to touch the encoder, you will get a shock. So all the equipments, earthing is required. It is suggested to every equipment whatever is going to be used in the studio or control room. UPS supply is required. Otherwise, if there is power cut, your stream will break. You will not able to transmit your data, and there will be a break in the signal. Same is the encoder is rack mounted. Means all the things, whatever equipments we are going to use in the PCR studio, it should be properly earthed. Otherwise, there is a chances that you have to touch the devices. If you are going to work, you have to touch the devices. You may get the shock. So all those things, all the equipment should be earthed, and it is also required to prevent the equipment from damage. Right. So this is the steps to start the encoder. So encoder is in the first front view I have shown there. Yes, like here. It's compact like this. So front view, there is a lock. So that should be opened with the provided key. Yeah. So after opening the key, opening the lock, we have to connect the power supply. Then in the front there is a red button. We have to press it to switch on the encoder. After pressing the red button, there will be a blink of light, green light. That will be blink. And when it is switched on, everything has been done. We are giving a input to the encoder. That is we are giving a SD SDI or HD SDI. That is input is BNC input. And after that, we are connecting it through the internet, by which we are going to transmit our signal from encoder to decoder. And if we have to go in the settings, we have to see what we are sending. We have to go to management port. That is other port in the Ethernet port was there. So we have to connect your signal to laptop to see the web interface. So this is the web interface to log in, and you can see all the settings there. Next video. So we have made a small video how we are connecting. So this is the video. Full करना एक बार screen zoom करो. So for the web interface connection in the laptop, we are giving the IP addresses that is provided with the box of the encoder, or you can take from the BISAC. So you will get after giving the input IP addresses, you will get one user ID and password. By that password, you can log into the web interface.
All the setting will be done at once only.
Yes, all the settings will be done by once, and with the help of BISAC, it can be done very easily. So after giving the proper IP address, now we can log in. The interface will look like this for the login interface. So after login, you will see the dashboard. This will be the dashboard after logging. Dashboard पे अच्छा ये video play करो. So there are jobs that we have to play. That jobs are our input signals, our final audio video input that we are going to transmit over the internet and sending it to the decoder BISAC.
आप सिग्नल कहाँ से दे दोगे इनको? सिग्नल तो
हमारी स्टूडियो का फाइनल आउटपुट SDI इनपुट देंगे मैम.
ये बता दो इनको.
अब वो
कैमरा से जो आपका फीचर में आएगा.
जी final output जो भी production whatever production we are doing in the from PCR, the final output that is going to be given as an input to the encoder. Right. Forward करो.
ये सारी चीजें आपको सिर्फ एक बार में ही करनी
Okay.
है, बाद में नहीं.
स्टॉप कर देगा वीडियो. मैं इसमें दिखाता हूँ PPT में. So once we have logged in the web interface of the management, you see this is the dashboard where you can see all your input jobs. Jobs means here is the input signal what you are going to transmit. So how much space it is taking, what are the processes going on, all these things will be visible in the dashboard. So once you have given the input to the encoder, you can see your all inputs in the Pixfix Versa. When you are going to the jobs, click on the jobs and Pixfix Versa. There you may see what are the inputs available. So here we have taken one input, second one is the color bar and tone pattern. So we have to start that input that is going to be streamed. If you are not starting, it will be look like this in the input preview. There is no signal. Once you have started your signal, once you have started transmitting your signal through the encoder to BISAC, you will see the input preview like this. So whatever input you have given to the encoder, you may able to see. Similarly, you can see the stream preview also. This encoder is taking 2 inputs at a time. So 2 jobs can be done at same time, simultaneously. And it can be either a similar same signal, it can be different signals. So suppose if we are going to transmit a live stream and in between we have to give some filler or some promos or some ads. So second one can be played in that place of first. Different things are there and that can be played. Also in between, if you are playing from your signal, from your studio, from your PCR, there also you can play the ad. In between, if there is any issue, suppose your link has broken, internet is not working or something has happened, you can give the color bar and tone that is stored in your encoder. This encoder has a storage capacity of around 1 TB that can be expandable up to 12 TB, I think. So you can store your program also, you can store your presets also, images also, whatever you are going to use in a live stream. These are the settings available inside the Pixfix encoder. All the settings and configuration will be done with the help of BISAC. So I think there will not be any difficulty. You will get full support from the BISAC in configuration of the encoder.
Not support is our job.
Yeah, it's the job. So here in notification, if your input is going on, but there is any break in the signal due to the internet, or there is any connectivity issue, so you will get a notification here. Your signal is getting breaked, your signal is not playing, or if there is any error in a signal due to some formatting. So all notification will go there, like job error is there, input error is there. So everything you can see in the notification. These are the user agreements that is not required for us. This is the nodes where you can see all the settings of Pixfix. So these are available settings that you have to set once when you are starting the encoder, and after doing all the settings and configuration, it's all set to start. Yeah. Okay. Any queries? Anything is? Okay, so
बाद में करी जाएगी, आप नंबर नोट कर लीजिए, सबका ईमेल आईडी नोट कर लीजिए, all the problems will be resolved.
PPT शो करना. Which one? Okay.
ये पीपीटी शेयर कर रहे हैं,
PPT PDF दे दूंगा मैं इसका आपको.
सब लोग बोलते हैं लेकिन भेजते कोई नहीं है।
ड्राइव लिंक दे देंगे आपको. नहीं, आप कोऑर्डिनेटर से बात करिए अगर आपको नहीं मिल रहा है.
Whatever presentations are being done here will be shared with you in the group, in the PDF form. Otherwise, certain number है ना. हाँ, बिल्कुल. Thank you so much,
So,
sir.
Thank you so much, all of you.
Now, we have our, thank you, ma'am. We have Rajesh Patel ji from Bisect